to introduce our speaker of today. May I introduce the Associate Head of Physics Department, Professor Shizhong Zhang.
Thank you very much. Welcome, dear guests, teachers, and students. Welcome to the joint Faculty of Science Public Lecture and Department of Physics colloquium, Hacking Stars to Better Understand Our Universe. My name is Shizhong Zhang, and I'm the Associate Head of the Department of Physics and a professor at the HKU. It's truly an honor to have you all here today to attend this talk delivered by the distinguished astrophysicist Dr. Hakeem Oluseyi. Dr. Oluseyi is a globally recognized astrophysicist and education advocate with a long and illustrious career in academia and scientific research. Despite facing numerous challenges, he pursued his passion for science and earned a Bachelor of Science in Physics and Mathematics from Tougaloo College, followed by a Master and a PhD in Physics from Stanford University. Dr. Oluseyi authored a book titled A Quantum Life, My Unlikely Journey from the Street to the Stars, which offers inspiring accounts of his journey. He used to serve as an astrophysicist and space science education lead for NASA's Science Mission Directorate, and is currently a faculty research fellow at the Princeton Plasma Laboratory. His contributions to the field of astrophysics and his effort to promote science education have earned him numerous awards and recognitions. In his talk, Dr. Oluseyi will discuss his cutting-edge work in interpreting electromagnetic radiation, laboratory plasma physics, computational modeling, machine learning, and high-performance computing. He will also share his unique approach to study stars, which involves hacking their properties to develop new technologies and deepen our understanding of the universe. Dr. Oluseyi is a remarkable example of hard work and dedication, and he continues to inspire and influence the lives of many. He encourages audience worldwide to pursue their dreams, sharing his roller coaster ride of success and the setbacks he faced. Today we have the privilege of hearing him sharing his knowledge and experience with us. Without further ado, please join me in giving a warm welcome to Dr. Hakeem Oluseyi, and let's sit back to get ready to learn how he hacked the stars. So, Dr. Oluseyi.
Thank you, sir. It's a pleasure. Thank you. Yeah. It's really amazing all you've accomplished for being 19 years old, but you look so young, right? All right, I'd like to share with you. So my host here from the U.S. Consulate asked me to share a little bit of my personal story as well as my journey to becoming a scientist. And so let's get to it. This is the book. Buy many copies. All right. And you'll get a little bit. I'm going to talk a little bit about my story. So here I am right now as a 4-year-old. And so I'm the little cute guy right there in the middle. The young lady with her arm around, oops, that is not what I intended to do. I'm trying to press the laser button. It's the one in the middle, there we go. Yeah, the young lady with her arm around my shoulder there, that's my sister. She's 5.5 years older than me. And right after this picture was taken, my parents divorced, right? So this photograph is from about 1971. I was born in 1967. And my childhood was pretty weird. Here I am with my grandmother, and so here I am as a kid growing up. See, I used to have an afro. It was red. I'm a redhead. And so basically, what happened with me is after my parents' divorce, my mother, we moved every year, literally. I never lived in the same state or the same city 2 years in a row. And my mother would literally leave me to live with other families, all right? And they would always abuse me. You know, I was beaten a lot, I was made to work a lot. And it really, I found my solace inside of books, right? So whereas most humans bond with other humans, I bonded with books. And that sort of is what led me to where I am now. And, you know, my family was pretty criminal, right? My father was a big drug dealer. My first cousins were all members of this Los Angeles social club known as the Crips. And these guys started robbing banks and worse. And when they went to prison, my mother felt like, you know what, I'm going to get you out of these inner cities, and I'm going to take you to the countryside, which you guys would call the village. So we moved to Mississippi, and I literally lived on a dirt road off a dirt road off of a dirt road. All right? And so my education at home was not based on academics. My father dropped out of school when he was 9 years old. He didn't even know how to read until he was in his late 20s. My mother dropped out of school when she was 16 years old and pregnant with my older sister. And as coincidence would have it, my mother's mother also dropped out of school at 16 pregnant, and my older sister Bridget also dropped out of school at 16 and pregnant. So I'm not just the first person to be a scientist in my family, I'm the first person to graduate secondary school in my family, right? And so I had no idea of what I wanted to be in life. But in my journey to read every book on earth, at the young age of 10 years old, we had a set of encyclopedias. So for everybody under 40 years old, imagine the internet in books, right? That was the encyclopedias. And this one year, I decided that I was gonna read our encyclopedias from A to Z. And I got to E, and I ran into Albert Einstein and relativity. And my brain exploded. And I said to myself, I want to learn relativity. So I started teaching myself relativity, all right, at the age of 11 years old. And so by the time I was 16, I had a lot of relativity under my belt. And luckily, the mathematics of relativity is really easy, as you all know. I was able to teach myself. But then, you know, I started high school in 1981, and personal computers came out for the first time in the 1980s. And my girlfriend, for Christmas, received a TRS-80 Radio Shack color computer. And, you know, back in Mississippi in the country, we didn't date. We did what we called courting. And the way courting works is on Sunday, the boy goes to the girl's house, you sit at opposite ends of the couch, the family watches you for 3 hours, and then you go home, right? So I thought to myself, why am I sitting here with you for when you got that computer thing over there? I'm gonna go learn how to computer. So it had a little booklet that came with it that taught this early programming language called BASIC, right? So I taught myself the BASIC programming language. And then that very same year, these professors from another university, they wanted to do outreach and they wanted to go where it was most needed. So let me tell you about my high school. Mississippi is known in America as being the state of the 50 states with the worst education. All right, it's absolutely true historically. And not only that, in around the year 2000, Mississippi evaluated all of its schools very rigorously. And 4 schools in the state received a failing grade. 2 of those schools were my middle school and my high school. So we can say that in all of America, we are truly number 1, all right? And so these professors, they wanted to go where they could make a difference, so they came to our school. And they told us about this thing called science fairs. And they told us that, you know, we had to come up with projects. And I thought to myself, oh, I know what I'll do. I like to program, I like relativity, I'll program relativity in 1983. So I end up going all the way and winning the Mississippi State Science Fair. And the professors say to me, they say, Hakeem, you have a big, huge head start in physics. You should become a physicist. But what they didn't know is that when I was 15 years old, I signed up for the US Navy. And there I am in the US Navy, in the barracks. You could tell it's the 80s. You see that big boom box right there? He's wearing a do-rag. That's my man Malcolm Smith from New Jersey. He's showing his toe off right there, you see. And so I signed up for the US Navy, and I don't realize it, but for me, this is a really lucky thing I've done. Because my education was so bad, the key thing that I wasn't ever taught well was mathematics. And when I got into the Navy, I got into a program that took enlisted people and gave you a year of academic education and sent you to college so that you could become an officer. And it was there that I learned algebra. There were two math classes, the regular math class and the remedial math class. Does that word translate? You know what remedial means? Yeah. Guess which class I was in? Y'all don't believe in me? You think I was in a remedial class? I'm a genius. What? Yeah, you're right. I was in a remedial class. And in that remedial class, they took us from arithmetic through calculus in 1 year. And before joining the Navy, I never even heard the word calculus, right? And so the other thing that happens, you may have heard about America and how we have issues with medical treatment. Well, I had always had this really bad skin condition. And where I was from, you just never went to the doctor, right? And in the Navy, they properly diagnosed me with that skin condition the first time. But the problem was you're not allowed in the Navy if you have that particular condition because of they can't trust that your readiness level is going to be what's needed, right? So I got kicked out of the Navy. And I go home and, oh, there I am. See, I was young and handsome back in the day. And I go home and my friends who had gone away to college, they hung out with me and we're sitting in the club and they start trying to convince me to go to college. And I didn't see a place for me in college because I knew you went to college to be one of four things: a doctor, a lawyer, a teacher, or an engineer, right? I had no idea what an engineer was. A doctor sounded pretty impossible. A teacher, that didn't sound that cool. And an attorney, like, aren't they evil? Like, I didn't, so I wasn't convinced, right? And they were like, oh man, we know you're a musician. We got a DJ crew. You can join us. Now I was like, I can do that here. And they were like, it's 5-to-1 female to male. And I was like, sign me up. So in 1986, I showed up at a small college in Mississippi, Tougaloo College, not realizing that I was supposed to apply first. And they got me enrolled in school. And this gentleman here was my chemistry professor. All right, Professor McGinnis. He's still there. He still makes me do stuff for him for free. And Professor McGinnis, so my first 2 summers at college, I was homeless, right? I don't mean sleeping on the street homeless. I mean sleeping on your floor tonight, sleeping on your floor tomorrow night, that kind of thing, right? And at a certain point in that first summer, I found this guy and I moved in with him, and it turned out he was insane, like literally insane. And so the second summer, I thought, I'm not going to do that again. So I formulated a plan. Our dorms would close during the summer. And I knew, Mississippi is very hot in the summer. So I knew that if maintenance was working in one of the dorms, the air conditioning would be on. And because I used to break into buildings a lot, like I said, I'm from a criminal family, I would break into the dorm where maintenance was working because they'd have the air conditioning on in that dorm, right? And I would just sleep on the bare mattress. So the year that I graduated from, Tougaloo would only have from like 700 to 1,000 students every year. So in my year in physics, there were 2 physics majors, me and a guy named Lorenzen Dunbar. And Lorenzen worked on campus in the admissions office. And Lorenzen, he passed away in 2008, but he was a hilarious guy. He was about this tall, and his name was unique. So when he would meet people for the first time, they'd often say, what a beautiful name, Lorenzen, I've never heard it. Does it mean anything? And Lorenzen would say, yeah, it means my mama black. So it's a thing, if you've been to America, right? So Lorenzen comes and wakes me up early in the summer of 1988. And he says, hey man, we got a call in the admissions office from the University of Georgia asking for you. They want your social security number so they can have your check ready when you get there. I had no idea what he was talking about, but I know exactly what a check is. So I went there, I called them, and they told me that I had been accepted into their summer research program. So I went to my professor, Professor McGinnis, and said, hey, Professor McGinnis, do you know anything about that? And he looked at me with that same expression. And he goes, oh, they accepted you. Wonderful. So what happened is they had gotten a grant for their summer research program pretty late in the year, and they didn't have time to recruit. So they contacted professors they knew and asked if they could recommend anyone. And Professor McGinnis recommended me. And I said to him, I said, well, you know what, Professor McGinnis, thank you very much. But I don't have a car and I don't have any money. So I don't have any way to get to Athens, Georgia. So thank you, but I'm not gonna be able to take full advantage of it. Professor McGinnis went into his own pocket and bought tickets for me to go to Athens, Georgia to do my very first research project. And I didn't even know what research was. And I worked for this guy, Michael Duncan, all right, in physical chemistry. And on the first day, he changed my life. Here's what he did. He took me around the lab, he showed me the work that they did in the lab, and then he told me what he expected of me, and then he said, scientists keep really strange hours, and you're gonna need access, so here's a key to the building, a key to the lab, and a key to my office. Of all the things I had received in my young life, one of the things I almost never received was trust. And this dude just gave me the keys to the building. I robbed them blind at something. Just kidding. I did not. So I did my work, and at the end of the summer, they say, man, you're really good at research. You should become a researcher. And again, it was the same thing. I was like, wait a minute, you're judging me on the merit of my work? Oh, this researching is a thing to do. So I go back to Tougaloo College and drop out. Why did I drop out? Because a part of that criminal family thing that I had, my dad was a big seller of certain products that grow from the ground. All right? And at this time, things were changing. He was not able to import that product anymore. And so a new product was sweeping the streets. And my father began to use it. And my brother began to use it. And then I began to use it. And I found myself in big trouble. And by midterm of the fall of 1988, every grade on my transcript was an F. I was failing every class. And so I knew that if I was ever going to get another penny to do college, I could not have Fs on my transcript. So I dropped out of college. And I had to get a job. And so I got a job working as a janitor in our nearby hotel, right? The Ramada Renaissance Hotel. And I was making $4 an hour. So I don't know if that translates, but that's not a lot of money, all right? And so I was making less than $100 a week living on my own. And so I didn't even have money to eat food. So what I would do is when I would show up to work, when people order room service, when they're done with their tray, they would sit it outside their door on the floor. So the first thing I would do every day when I would go to work is I'd walk through the halls and eat the leftovers from people's trays, right? And then my big break came, my big break. And that is one of the bellhops got fired. And I thought, if I get the bellhop job, I'll get tips. And I can make $100 in a day. And I applied for the bellhop job, and guess what? Didn't get the bellhop job. So I thought to myself, I can't go from janitor to bellhop? I'm going back to college. So I re-enrolled in college, and just as I did, this woman showed up on our campus. Her name is Dr. Cynthia McIntyre. She was in her last year of a PhD in physics at MIT. She was going to be the second African-American woman to achieve a PhD in physics from MIT, and she had an idea. She was like, there are no African-Americans in physics, generally in the country. Let's start a conference to help people to learn about the field. And so they came down to Tougaloo College, and they told us, hey, we'd like to bring you to MIT and tell you all about physics and how you can have a career in physics. And I went to MIT, and that's the first time that I learned that you can have a career in physics. And I met the other physicists. And one of them happened to be this guy. His name is Arthur Bertram Cuthbert Walker II. And he was a professor at Stanford, and he became my PhD advisor. I got accepted to Stanford. And by some miracle, I get accepted to Stanford University, and I go to Stanford. There I am in my Stanford office, and you can tell, I got problems. You know what I'm saying? I got attitude problems. I was always telling jokes and robbing people. So anyway, what happens is, there's no sound, so I'm gonna have to skip that next one. So what happens is, we start observing the sun together, all right? And at the time, this is the early 1990s, And today, we have images like this from the sun every day. Well, Art Walker had recognized that this guy down the hallway had invented a new technology that would allow us to get images like this. And so those images, all of these ones, here's NASA's fleet of sun-observing satellites. All these 5 observatories all use that same technology, and we were the first to do it. And this is what our data looked like. We actually use photographic film, not CCDs or anything like that. That's why you see these horizontal lines. That's because the film would crack under vacuum. But this is that early data. And so when I first saw this, I was like, that's the sun? It didn't look, that's what I was used to seeing. And now there's images like this. And I, became really fascinated with the interaction between light and matter. So I thought of a question I always ask my students, right, when they start new. And I ask them, I say, where does light come from? And the answer I tell them is matter makes it. And when matter makes light, the signature of what the matter is and what the matter is doing is encoded in the light. And that's why we're able to look at a dot in the sky and say, here's what it's made of, here's what its temperature is, here's the mass, here's how, the direction it's moving, right? Here's how old it is. And so that just really fascinated me. And here's the technology, it's called multi-layer technology. So basically it's too complicated. But here we are flying our rocket in the early 90s. Are you guys familiar with the show called, what is it called? The guy, Giorgio with the hair? Ancient Aliens. Oh, yeah. Yeah, you know that show? Well, this guy, Richard Hoover, he's a NASA scientist. He's always on that show. I like pointing that out. So this is Art Walker. This guy is now a professor himself. This guy's at Lockheed. I don't know where he is. I hope I never see him again. And that's me. So what we would do is we would fly 16 to 22 telescopes at a time. So in the summer of 1994, I spent the entire summer constructing this thing. So every hole you see here goes to a different telescope, right? But what I did is immediately after graduate school, I did not go and become a physics researcher at a university because Stanford is in a region of the country called the Silicon Valley. And what is the Silicon Valley associated with aside from silicon and computer chips? Money. And I told you how I grew up poor. I was like, I'm gonna go get some of that Silicon Valley money, right? So I got a job at this thing called Applied Materials. And the reason why is my experiments for calibrating these instruments were inside of vacuum chambers, and I studied plasmas. And how do we make chips? Using plasmas inside of vacuum chambers. And when I get there, there was a problem that people were working on. And that is that, every time you make a chip on a silicon wafer, there's all these processes of laying down material, removing material. And the way that it works to make sure you get it right is, after you process a wafer, there were certain wafers that were in there called test wafers, right? And so you get those out and you test them to see if the last process worked properly. If it did not, you have to throw away all those wafers. And if you're far along in the process, that would be very expensive, tens of thousands of dollars, if not hundreds of thousands of dollars. So this one scientist named Moshe Sarfati had the idea that by looking at the light emitted by the plasma, we should be able to tell what is happening at the wafer surface, and then we could change the settings on the instrument and make sure it gets right every time. So instead of testing it after, in real time, we would do in situ process diagnostics and control. And they had been working on it for 3 years and it got nowhere when I joined the research group. And then I joined and I came with my astrophysics knowledge, right? And so here's a process for my research. So this is a 3D spectrum. On the x-axis here is wavelength, is time. The y-axis is wavelength and the color is intensity. If I slice across it at one time, you get a spectrum that looks like this. So I did what you today would use machine learning to do, but I did it in my head. What did I do? I identified all these different peaks, right? And so I have these wave bands, and I came up with how changing the pressure, how changing the settings change the intensity of the light that was coming out in these different bands, right? And I came up with stuff like that. So for those of you who are not a scientist, if you have data and it's on a straight line, you just made a big discovery. So this project led to a bunch of patents for me and a whole new division of the company, right? So along with my discoveries in solar physics, I started getting this name for myself. And I felt like, you know what? I hate working here. Corporations have these crazy rules. They want you to show up in the morning, stay all day, and worst of all, they have this thing is horrible. They call it, what do they call it? A boss. So I'm like, this is not the place for me. So I came back to fundamental research. And I felt like solar physics was a little boring to me. And I was always interested in cosmology and the universe. So the very first research I had ever done in physics was in studying dark matter. And the same group had a job announcement because they had just made a big discovery. They had discovered dark energy, right? Saul Perlmutter and those guys. And so when I joined them, here is their data where they had discovered dark energy. They were now planning a new satellite. And in order for that satellite to study the high redshift universe, the engineer at Lawrence Berkeley Lab named Stephen Holland had invented a new type of detector. But the problem is, the phrase research and development? They were stuck in research and could not get to development. And they, Hakeem, you were in the commercial world. You know how to get the thing out the door. Go get in our lab and make our detector something that the whole world can use. So this is what the focal plane, so I work with engineers, we developed this model of the instrument, right? And so this CCD in astronomy, typically they were like 20 microns thick, really thin, and what that meant was that they didn't have really good red sensitivity. Their quantum efficiency would fall off in the red. And Steve Holland figured out a way to make the silicon extra pure so that you could make it really thick, and then you ended up with almost 100% quantum efficiency because silicon becomes transparent at 1.1 microns, and the infrared detectors, they peel off around right here. So you had to use the silicon detector to have high efficiency out to there, and Stephen was able to achieve that. Now, the other problem that I worked on is this would be a large focal plane. And if you look at detectors with large focal planes, the piece of silicon here that is the detector, it has to have both a mechanical and an electrical interface. So if you look right here, you see those gaps? They're there for the electrical connectors. These are just in a completely different plane from each other. And what we wanted to do is something like this, tile a complete surface. So my job was to come up with a 4-side buttable packaging, which is what I did. Along with, nobody does anything alone. When I say I did something, I and a team of a few people, right? So this was a team of 3 people, me and 2 engineers. One of them was, a German guy, Armin Karcher. And I was like, Armin, how do you know everything? He was like, when I was a kid, I read this book called How Everything Works, right? So we're kind of similar in that way. And so here it is, that same detector first went on the dark energy camera, and that's what it looks like. And it's also going on the Vera C. Rubin telescope, and this is an image of their focal plane, right? So I had that little tiny role there, and I also worked with Brookhaven National Laboratory on how to calibrate these things. And so I left Berkeley, got a job at NASA and a university in Alabama, but I don't know what you know about the history of Alabama, but after 3 years, I had enough of Alabama. And I tell you what's funny is that, I grew up in Mississippi, and you know what the people in Alabama say? Because, it's not the best place in the world. Their motto is, at least it ain't Mississippi. So, true story. So, I think, the type of work in instrumentation is very expensive. And so when I was working at NASA and at university, I could go to NASA engineers and say, hey, make this drawing for me. Let me use this lab over here. When I got to the Florida Institute of Technology, which is a much smaller university, I no longer had the support. And that meant that I would have to pay for everything out of my own research budget. So I thought I need to do some research that's a lot cheaper. And I also thought to myself, I'd like to develop the modern skills of tomorrow. And what is that? Big data analytics, machine learning, right? So I thought, okay, who's the best in the world at that? The people that were involved in the Sloan Digital Sky Survey, and there was a guy named Željko Ivezic who works at the University of Washington, who was one of their top scientists. So I was like, yo, Željko, teach me how to do this stuff. So I started working with the LSST team. This is now called the Vera Rubin Telescope. And we were looking at what is known as galactic archaeology. So the model of galaxy formation is what we call hierarchical galaxy formation, right? So smaller things coming together, build up larger things. But one consequence of hierarchical galaxy formation is that a large galaxy like the Milky Way should have so much debris around it, and in terms of dwarf galaxies and tidal streams, there should be something like 200 of these things surrounding our galaxy. By the 90s, we knew of 3. By the time I started this project, we knew of a few more. And so I started working in this project. And so the idea is this. If you look at the galaxy, there is the disk and the bulge. The material is incredibly dense in comparison to the region around it. So that means that any structures that are in there that are a part of something that came together to build the galaxy will get torn apart gravitationally on a relatively fast time scale. But out here in the halo, they can survive for very long times. So our idea was to look into the halo and see if we could find all of these different structures, but also we want to understand the galaxy as well, right? So we want to understand how to measure the properties of these things. So here is what our galaxy should look like. Here is the modern map of all the actual dwarf galaxies that we found now. Now we're up to like 3 dozen, right? So, yeah, that's another picture of the same thing. So I started looking in globular clusters, which are these bunches of stars that are the oldest stars that we know of in the universe. There's about, on average, a little under 1 million stars and a volume of 100 light years. For comparison, if you look at the region around the sun, there's only 60,000 stars within 100 light years. In a globular cluster, you have 1 million stars packed into that same volume, right? And so there's these stars that blink. These are called RR Lyrae stars, right? They're pulsating. When they're small and hot, they're really bright. And when they get big, they're dimmer. But the thing about them is that they dim and fade in a very particular pattern. Excuse me. So when you see one, you know that that is what you are seeing. Let me check the time. I feel like I've been talking for about 4 hours. Okay, we're good. And we call it a standard candle. And so we did a survey, we did a data survey. We studied 5 billion observations of 24 million objects in order to get a subpopulation of RR Lyrae stars and then map them out in space and then use a statistical model to see if they are overabundant in any locations in space. And we discovered a few dwarf galaxies as well as some tidal tails of globular clusters. And then, while I was doing this work, I still had a research group doing plasma physics. And because I had success with taking the knowledge that I learned in one area and applying it to an adjacent area, I told my students, pay attention to adjacent areas. And the work we were doing in solar physics, I was focused on certain types of phenomena that are self-similar in scale and variant. What that means is the same process occurs on many different scales. So my graduate student came to me and he said, hey, there's this process, this is supposed to be a video, there it is, where these jets shoot off from the surface of the sun. There's this particular type of magnetic reconnection called torsional spine reconnection. It happens on the surface of the sun on scales of millions of kilometers. It happens in planetary magnetospheres on scales of kilometers and tens of kilometers. And it happens in the centers of galaxies on the scales of a few light years. So it appears to be scale invariant. If we're able to do this in the lab, these structures, these jets fly off at 3,000 kilometers per second. If we're able to harness this and do it in the lab, we'll have the world's fastest ion propulsion technology. So we set about doing that. And so here is the model of what it is. you have what is known as a fan and spine. Here are simulations of these things. And so what happens is that you end up with a situation where you have a bunch of magnetic field lines that all point inwards toward the spine, right? That's right here at the spine. And the magnetic field goes to 0 at the spine, right? It's called a magnetic null. And so if we want to harness this, there's 2 things we have to do. To make this, you need to create this magnetic field configuration in your lab, which is not trivial, and you have to perturb it in just the right way to make it reconnect. So people had modeled this process. So what you see right here, you're looking down the center of the spine. And this image over here is if you turn it 90 degrees, all right? And so imagine a torsional spine just exists. And this is a second magnetic field that starts off large and then collapses. And when that happens, you end up getting this jet of material at 3,000 kilometers per second. So now we have to create 2 magnetic fields. We have to create the fan spine configuration. Then we have to create this collapsing annulus around it. How the heck do you do that? So, you do research and figure it out. So it turns out that near us was this company called Advanced Magnetic Lab, and they could model this process, and they came up with a design for us, and it was too expensive. This thing will cost $30,000, right? And so we made it ourselves in the lab, and we came up with different configurations where you run currents through these, and this is the magnetic field model that we got using COMSOL, and we found 3 different ways to do it. And how did we have the perturbing field? Well, it turns out that the people who studied nuclear fusion created a device called a dense plasma focus. So what you do is all of these are electrodes around the outside that are held at one polarity, magnetic polarity. In the center is the opposite magnetic polarity. You connect this thing to a bank of capacitors. You have a dielectric at the back. And when you hit that thing with that bank of capacitors, that strong field, you get a plasmoid that forms at the back, flows to the front, and then collapses down. And it collapses down so hard that they actually create fusion, right? We don't need it to do all that. We just need this magnetic field collapsing. And so we also built that in the lab, and boom, there it is. It works. So my students went and created a company. So now they have a company, and I'm no longer doing this. But the other thing that happened with me is, stars is a metaphor for our future, right? Read the stars. And so when I was at the end of graduate school and I was teaching, I suddenly realized people kept telling me the same thing. I TA courses. I teach courses, as a graduate research assistant, right? Graduate teaching assistant. And students will say to me, Hakeem, I got my only A from a science course from you, right? And then when I was in Silicon Valley, I would teach at night at a junior college an astronomy class, and people would come to me and they'd say, man, I didn't know that I could understand astronomy. And I didn't know it was this cool. So I've now decided to go to college full time to become an engineer or something like this. And I realized that what everybody was saying to me was, Hakeem, I thought I was dumb until I met you. So for me, it became sort of a responsibility, right? Because my life was changed tremendously by my education, and I knew that everybody didn't see the opportunity, because if you live in a world where no one around you has achieved life, abundance of life through education, you really don't have an understanding of it. So I started working, and by the way, where's my buddy? My Kevin Hand lookalike. Is he in here? There he is. So in 2002, I went to a conference, and on the ride from the airport, there's a guy who looks like him, and I say, hey, I'm Hakeem. He goes, hi, I'm Kevin Hand. I'm a graduate student at Stanford. And I go, no way, man. I just graduated from Stanford 3 years ago. And we start chatting. And then the next day, when I woke up at noon to go to the conference, you're supposed to laugh. I woke up at noon, right? I go to the conference, and there's many talks going on in many rooms. And so I look at the posters outside of the rooms to figure out where I'm going to go and listen to a talk. And I see one poster with the title, Physics in Africa. And I go, oh, let me go in there. And I go in, and who's talking? But Kevin Hand. And Kevin, have you guys seen Jeff Bezos has a sounding rocket he sends people up in? And every time he sends people up, there's one person that actually paid their way. And on the third trip, there was this one guy who runs a company that takes an image of every location on the earth every day with these satellites. Well, that guy founded that company with another guy named Will Marshall, right, from England. Will Marshall and Kevin Hand were going around Africa to schools and making students excited about science. And that's what Kevin was talking about that day. And I said, Kevin, how can I be involved? And Kevin said to me, man, it's not a question of can you be involved, you must be involved, right? So I said, okay, so I go home and I don't hear from Kevin for another 7 months. And in September of 2002, he sends me an email. It's like, hey, Hakeem, remember we met? I'm like, yeah. He's like, we're all going to Africa in November. There's a total solar eclipse in South Africa and Botswana. We want to pay for you to go. And I'm like, that sounds great. But the problem was, I had made an error in the lab that had set my time schedule back by 6 months. And so I was like, man, I feel really guilty about going to take a trip to Africa. I really need to be in the lab working, right? And so I was talking to my different postdoc colleagues about what to do. And there was this one guy from India named Val Prasad. And Val was a no-nonsense guy. And so I tell Val, and Val says, let me get this straight. Somebody's going to pay your way to go to Africa, and you're trying to figure out if you should ask whether or not you should go. And I'm like, yeah. He goes, have you ever been to Africa? I'm like, no. He's like, do you want to go to Africa? I'm like, yeah, it's like a lifelong dream. He's like, what the hell is wrong with you? You shouldn't be asking them, should you go? You just tell them you're going. And I'm like, you know what, Val, you're right. And I went, and it became one of my life's passions. So here I am, not that first trip in 2003. You see, I had broke my hand playing basketball. You know, I was out there schooling them fools. And then some dude, I went up to get a rebound. This guy undercut me, and I put my hand down to break my fall and broke it. So that, you know, so that's that one. And here, this woman right here, her name is Susan Marabana Oduri. She was working in Kenya as an accountant. And she comes to me. And at this trip in 2006, we're in Ghana, and she says, Hakeem, I want you to take me under my wing. I want to get into astronomy. Susan has become a international superstar of astronomy. As a matter of fact, just last month, I was in Kenya. Do you guys know who Mae Jemison is? She's the first African-American female astronaut, and in America, she's super famous. Somehow, Mae and Susan connected, and so now they're working together. This woman right here, her name is Samaya Fareed. In 2002, I went to a conference, and a lot of people came to me like, Hakeem, you gotta meet this undergraduate named Samaya. She's like you. She's from Alabama, and she loves astronomy. So I talked to her, and I said, hey, Samaya. In fact, we're in Ghana getting data for her project. And I invited her to come to work with me. And at the end of the summer, I said, Samaya, you got it. You got the it factor. Come get this PhD and be a researcher. She goes back to school and graduates. 3 years later, I'm in Huntsville, Alabama, and I accidentally run into Samaya in a parking lot of the Walmart. And I say, hey, Samaya, what are you doing nowadays? Expecting to hear something grand and great. She was working in retail. And the reason why was because her family had certain challenges. Right? And she found herself having to look after her younger siblings, and she got the job she could get quickly. And I said, oh, hell no, Samaya. You need to go back to graduate school, become my graduate student. And today, she's Dr. Samaya Fareed, and she's held positions at Yale and Harvard. Now she's somewhere on the West Coast, right? And yeah, that's Jessica. She's an engineer at Boeing. These two guys are the guys that formed the company. This is the runway where I told whoever the story was, we almost got killed 3 times. Yeah, this is our crew right here. Yeah, and then in 2008, we got a grant from the Kellogg Foundation because South Africa has a distinguished history in astronomy, but historically all their astronomers have been British. And their government said, listen, you better start making some South African astronomers or we're going to take your money away, right? And so my colleague, Charles Magruder, who's older than me, he got this grant from the Kellogg Foundation. He said, Hakeem, you know as well as I do that the problem is not one of academics. I want you to come with me to teach these students. So what would happen is the top black students in South Africa would attend black colleges, just like I did. And then they go to the top colleges that are, everybody, and they would fail out. In their system, before you go into your master's or your PhD, you have to do what's called an honors course. And these students were good students, but they would all fail at the honors course and not go on. So when I showed up, they said, hey, here's what we test these students on in the honors course. What are you going to teach them, Hakeem? I said, none of that. And they're like, really? Then what are you going to teach them? I said, I'm going to teach them either quantum field theory or cosmology. And my professor colleagues say, wait a minute, that's way over their head. And I'm like, I know. And they know it too. And when I teach it to them, they're going to get it. And when they get this, they're going to realize they can get anything. And 3 years later, my colleague, Peter Dunsby, he said to me, Hakeem, I got great news for you. Not only have all of your students passed the honors exam, they've all passed in the top 20%. And South African astronomy has been completely transformed, right? So I now, do this stuff. Here I am, oh, there it is right there. We started teaching in 2008 and boom, that's what happened, right? So then I started working with these folks, the diplomats. Here I am in Algeria for you guys. Here I am in Indonesia. And now I'm here in Hong Kong, spreading the gospel. And so, the thing that I learned, I always talk about my story and I say I made it out of hope, hustle, and help. Without those people showing up, without Professor McGinnis recommending me for that program, without my Navy recruiter recommending me for Boost, without what's her name coming from MIT, right? I wouldn't be here. So I realized that in order, working together, we can accomplish anything, right? And so sometimes when you do, crazy stuff happens. And this is such a video, and I wish I had sound.
Command issued and lift off. Mark Vanda High, Alexander Mazurkin, and Joe Acaba lifting off and now on their way to the International Space Station.
I'm NASA astronaut Mark Vanda High on the International Space Station orbiting 250 miles above our planet. And it's great to be a part of American Graduate Day. I've been fortunate to have had great mentors in my life during both my Army and academic careers. In fact, while at Stanford University studying for a master's in applied physics, one of the people who helped me along the way was Dr. Hakeem Oluseyi. Hello, Hakeem.
I didn't know that was going to happen, by the way.
NASA is a wondrous blend of science, engineering, technology, with mentors at every step of the way. So become a mentor, just like Hakeem was for me.
All right, thank you guys very much. That's my colloquium. All right.
Okay, thank you very much. I think we still have time for a few questions. So there would be help for us to pass around the mic. So please raise your hand first so we can pass you the mic. So any questions? If you have, please raise your hand.
Oh, and if you're a rapper, feel free to drop a rhyme. And if you don't ask me questions, I'm going to think you hate me. They hate me. Come on, y'all. All right, here we go, my man.
Thank you.
Do you have any plans for the future? So you've talked a lot about the work that you've done in many different fields.
Yeah.
What do you think you'll go on to do next?
I'm trying to get rich, man. No, so I'm working with a new satellite project called IMAP, and I have a secret project that I can't tell you about. But let's just say that it is, if I give it's so easy to do is the problem, right? And so I have a good friend who has developed a new type of detector that's kind of unique that can be used for a very unique purpose. excuse me, if put in orbit around the moon, and if there is a positive detection of what we're looking for, it's no Nobel Prize type of a result.
Just like, you seem pretty motivated all the time. What motivates you? Like, especially you mentioned that your family's problems and things like that.
Yeah.
How do you get motivated? Because I find that usually in that sort of environment, people kind of set you down, they pull you down.
Yeah, you're absolutely right. You're absolutely right. So one thing is I never lived in the same city 2 years in a row, so I never fell into the mentality of any particular location. And then the other thing is that I had to fight so hard to live indoors and eat. I don't take it for granted, right? And so, I never want to be homeless again. I never want to, be starving again, So when I wrote my memoir, there are certain things that if you've been through it, I thought, the stories in it are so wild, I would think that people don't think this guy is lying. There's no way his life was like that. So I put all these little bitty things in that you only know if you know. Like, for example, if you go a couple of days without eating, the first time you eat something, what happens? Do you know? Huh? No, you don't even make it down your throat. The roof of your mouth is hit with so much pain. It's like, I don't know what causes it, but it's like a thing that happens every time. You've experienced that? Yeah, it's a horrible thing, right? But if you don't go through it, you don't even know it exists, And so for me, it's just motivation. You know what I call it? I call it immigrant hustle. Because if you look in the United States, right, there was people that come in, like my thing, when I got to Stanford, I was like, okay, you guys might be better educated than me, but nobody here is going to outwork me, right? So Friday night, Saturday night, I'm in there working, right, while y'all out partying. So then I go to Silicon Valley, and I'm thinking I'm going to use the same formula. I'm going to outwork everybody. I show up at work at Friday night, guess who else is there? The immigrants. Not the Americans, but all the immigrants. And I'm like, damn, I guess that's not gonna work, right? So, and then now, I'm really just motivated out of, it's no longer, it's sort of like pride in a way, right? I feel like I can't, let me change that. I hate to suck, right? I don't want to do badly. And, I get bored, so I always want to do something new. And so once you accomplish something, like for every success I've had, I must have had 1,000 failures. But no one sees the failures. They only see the successes, right? Like take Isaac Newton. That guy got real problems, but nobody knows about him. You got to be a real history of science kind of person to know what a jerk Isaac Newton was, right? So now you all are going to look it up, right? I consider him a murderer. So you know how, for example, coins, when you see ancient coins, they're all like misshapen because people would do what's called coin clipping, right? So if you look at American coins, the quarter and the dime has these little ridges around the edge, right? Isaac Newton invented that. And the reason why is that he got this position as the warden of the mint. And so if you had gold and silver coins, you could clip off a little piece, pass off the coin at value, and save the clippings, right? So coin clipping was illegal. And guess what the punishment was? Death. And so it was said that Isaac Newton was very strict at enforcing that rule, and he took great joy in attending the executions. Sounds like your kind of guy? No, no, he's a jerk, right? So I'm motivated out of, just like I want to do well. And the stuff that you try to do when you're a scientist is stuff that people, I never anticipated that being an astrophysicist would become cool, right? I didn't see that coming, right? And so nowadays people pay attention to science and your accomplishments in science. But when I was younger, nobody paid attention to kind of people like us. Right? We were just doing it for ourselves. And I still do it that way. Like the stuff I do, if you look at my social media, I don't like, hey, look at the great thing I do. I never do that. I'm just satisfied in myself. I don't, Yes?
Question in the back?
I have a question. So for the normal people, like
English majors? Oh no, go ahead.
like quantum and astrophysics seem like a really distant field from like daily lives of people. But how do you think it can inspire or impact normal people?
Well, it is, right? This is quantum mechanics right here at work, right? I mean, physics is all around us. The modern world is all physics. You know, Faraday, Maxwell, you know, Gauss, everything we do is air conditioning, right? That's that's physicists. You know, it's all around us every day, and you know, it's just a matter of allowing people to see it, you know, and letting them know what it is. And I know it's hard, right? So, for example, when I work in Africa, when a student graduates with an undergraduate degree, they're expected not just to contribute to their family, but to their tribe and their village, right? And so if you're like, oh, I'm not gonna get a job now that I've completed my undergraduate degree, I'm gonna go and get a PhD in physics. Your family does not want to hear that. So a lot of the process that we had to do was actually talking to people about how to talk to their family so they will allow them to do something that sounds like, you know, it's of no use, like physics and astronomy, and convince them that actually it is of great use. And not only that, if they do it, they actually make as much money as if they went and worked at a corporation, right? So, yes.
Okay, so you've met a lot of people in your life, right? So just wondering, just being curious, was there a case where there was a person or a mentor in your life where you didn't believe in them at first, but after some period of time, then you really realized the merits of their ways?
Yeah, my PhD advisor, Art Walker, right? He wasn't really my kind of guy, but he was the guy I trusted. And we would have these debates about certain like social things. And you know, with time I learned that I was wrong about everything. Right? And I changed how I thought. Like, I'll give you an example. Where I grew up, it was racially segregated, right? So I went to the all-black high school, a mile and a half down the road from the all-white high school, right? And when I left Mississippi to go to Stanford at 24 years of age, I literally thought all white people are racist. And then I got to know people. And I realized, oh no, all people are individuals, you know, and it's not, you know, whatever group you belong to is not a reflection of your character or abilities or anything, right? It's individual by individual. And I used to think crazy things like, oh yeah, African Americans are better at football and basketball because this, that, and the other. And he go, you know, I'm a big baseball fan. Did you know in the 1920s, baseball was dominated by Jewish people? And I was like, no, isn't it Cubans? He's like, yeah, today, but back then, and people thought they were like, you know, naturally, you know, but it's crap, you know. So I had a lot of crap in my head, right? And I had to learn other ways of thinking. And you know, I always say, art turned me into a scholar and a gentleman.
Yeah, that's a question.
Aside from my language, but go ahead.
Okay, that's a question. Some of us undergrads would like to receive some guidance on astrophysics or quantum mechanics. What are some of the ways you can contact you or your colleagues, or are there any other resources you would suggest? Yeah, no, I think what you're saying is the exact right thing. You know, apprenticeship is kind of the way it works. You know, having access to the people that are actually doing it is the best way to learn it. But you need actual problems to work on if you want to do it well, right? So there are people, like I have a guy right now, he's doing amazing stuff at the National Radio Astronomy Observatory, but academically, he was a C student. In the research lab, A++++++, right? And so when he applied, I happened to be going there. And the guy said, hey, we got an application for this guy. What do you think about this guy? And I was like, oh, he's number one. He's a top-notch guy. Hire that guy. If they had just had him on paper, they would not have hired him, right? And so if you want to go to some other university and you are not academically the greatest whatever, but the professor at that university knows this professor and asked him about you, and he has a good recommendation, he's going to take you over the 4.0 student, over the straight A student, right? So getting access to people, and also, you know, just being in the presence of him, you know, you by osmosis, you learn how to be and think. And, you know, because there is a language of the field, there's expectations, there's ways to think, and it's not natural. Thinking like a physicist is not a natural way to think. Like I always say that the greatest lesson I learned in graduate school was the difference between knowing and not knowing. For example, Art would say to me, Hakeem, did such and such happen? I'm like, yeah. He's like, do you know that happened? I'm like, yeah, I told Craig, and he's like, oh, do you know that happened? Like, yeah, Craig walked out the room and he said he was gonna do it. He goes, do you know that happened? And I'm like, I'll be right back, right? Right? You know, if you don't confirm it to be true, you're believing it, you don't know it, right? And so little subtle things like that, right? And you know, I always tell my students, you know, when you make a plot and you got that point with the error bar, I'm like, all the science is in that uncertainty. It's not the dot, it's in that error bar. And understanding uncertainties and systematic uncertainties and statistical uncertainties and all these different types of things is where the science really is, right? That's where the rubber meets the road. Because let me tell you, when you make some discovery and you share it with your colleagues, how do you think they react?
I don't know what this is.
They say, you think they say, Hakeem, that's amazing. No, they say, Hakeem, I hate you. Yeah, and then they nitpick every little tiny thing. So you know the story of Srinivas and Chandrasekhar? Okay, so Chandrasekhar was this Indian guy in India, and he was trying to figure out what happens to stars at the end of their lives. And you know, neutron had not yet been discovered. And he calculated, based on this thing called electron degeneracy pressure, you know, how this leftover remnant would behave. And he found in his calculations that when the mass of the white dwarf, we call it, reached 1.44 solar masses, something crazy would happen. But he didn't know what, okay? But you know, the physics kind of broke down. So he writes up his manuscript and he sends it to Britain's Astronomer Royal, Arthur Eddington. And he says, Eddington, check my work. Is it good? Did I do anything wrong? And Eddington says, no, it's fine. Because Srinivas and Chandrasekhar was about to present it at a conference. So Eddington contacted the conference and said, make sure I speak immediately following Chandrasekhar. Chandrasekhar gets up there and gives his talk, and then Eddington gets up and gives his talk right behind him and tells why what Chandrasekhar said is not right and not gonna work, right? So Chandrasekhar kind of went into isolation after that. And it's kind of good for us because instead of doing the normal thing of writing papers every year, he would just work out something really deep and then write a book, right? Stellar Interiors, right? And he ultimately, like 30 years later, I think, won the Nobel Prize in physics. Yeah, he was right all along. I'm gonna wrap up because I'm starting to sweat.
All right, well, how about this? Due to the time, let's say one last question, if there's one urgent question.
Yes.
What do you think are some essential skills high school students can develop outside of academics to achieve a high level of exposure in the field of physics?
Well, exposure is, you know, I don't, you know, a lot of people talk about networking and exposure and that kind of thing. To me, I never like seek that, you know. I do seek relationships with whoever is the best at it. I want to come learn from you, right? So if you have a university in your town, you know, even if you're not getting paid, start showing up to group meetings and start listening and understanding and getting in it, right? But also, when I have undergraduates come work for me in my research group, I assume that you're not necessarily going to become a physicist or an astronomer, but you're likely going to be something technical. So I say to myself, what skills can I give you that are going to be transportable that you can use anywhere? Because that's what has allowed me to go from field to field is a certain set of skills. So because I was instrumentation, I'd make sure you know some electrical skills, some mechanical skills, statistics, and coding, right? Those things will take you far and wide, you know? And then if you have, you know, good reasoning abilities in mathematics generally, you know, you can go far and wide, but communication is very important. And there's spoken communication, there's scientific papers, there's posters, you know, there's all these different ways we communicate. And the more effectively you communicate, the more effective you are in everything. All right, thank you all so much.
Thank you very much.